In mathematics, a set is a well-defined collection of distinct objects. We call the objects in a set its elements or members. Let's talk about these two properties. What does it mean for an object to be well-defined and distinct? Well, first of all, each element of a set is either in the set or not. There's no ambiguity. For example, the set of even positive numbers is well-defined. Let's call it E, and we will find the elements 2, 4, 6, 8, 10, etc. Each element is either in the set or not. So 6 is in the set, 4 is in the set. The number 3 is not in the set. There's no ambiguity here. When you define a set, it must be clear whether an object is in the set or is not in the set. An unclear definition of a set would be the set of beautiful numbers, which of course is subjective. So this is not a well-defined membership. Now what about elements being distinct? This means that 4 only appears once in this set. Same thing for 6, 8, and for every other element of the set. So there are no 2 4s, no 2 6. Each element is distinct. This is a very important property of sets, which is often used in computer science data structures, for example. Sets are usually written with curly braces, as I've done here, and we can also define them using a property. For example, set A equals X such that X is a positive number less than 5. We are describing the set through one of its properties. In this case, it would be easy to list all members of the set. So we could just do A equals 1, 2, 3, and 4. The definition using a property is also called a set builder notation. Now, if X is an element of S, we write X is an element of S, or X belongs to S. So 2 belongs to A. If an element Y does not belong to S, we write it like this. Y is not an element of S. Here, for example, 5 is not an element of A. Sets can be infinite, so this one is an example, hence the ... And of course, they can also be finite, like this one. If every element of a set B, let's say B is this set, is also an element of a set E, which is the case here, we have 2 and 4, which are elements of E. We say that B is a subset of E, which is written like this. B is a subset of E. Or we can also say that E is a superset of B. We can also read these as B is contained in E, or E contains B. Note that these two statements are logically equivalent statements. If one set is a subset of another, then the second is a superset of the first. What if we have a third set here called C, which is the set of the elements 2 and 4, which allows us to say that B is a subset of C and C is a subset of B. When this happens, we can say that the two sets are equal, and we write it as B is equal to C. Finally, a very important set is the empty set. So let's create a set D here, which is the empty set. It is represented like this, or you can also have empty curly braces.